Good evening, everybody, and welcome to this Thursday night webinar. My name is Bruce Stevenson, and I have the honor and privilege of chairing tonight's webinar. Early start for us tonight, but it's going to be fantastic. Quick word of welcome and thanks to Dynaval, who are our sponsors for tonight. As the evening progresses, you will get to know more about them, as well as our two speakers. There will be some poll questions tonight, so stay awake, pay attention, and participate. It really does help the speakers when they're getting feedback on polls. So please put the effort into answering those polls by clicking on the correct answer as you feel it is. Remember, there are no wrong answers, and it is anonymous, so don't be shy. As I said, tonight's webinar is brought to you by Dynaval. And we will be having a Q&A session at the end. If you want to speak to or ask the questions, shall I rather say, of our speakers tonight, just move your mouse on the screen. A little control bar will pop up. You'll see a Q&A box there. Type your questions into that. They will come through to us, and we will hold those over to the end. So two speakers tonight, which is a little different, and it's going to be great. Our first speaker, Dr. Esteban Bala, is a vet who has been devoted to bovine reproduction technologies since his undergraduate years, when he started to collaborate with the IRAC, which is the Cordoba Animal Reproduction Institute in Argentina. He then obtained postgraduate advanced study certificates in bovine reproduction technologies as well as bovine production, whilst managing his veterinary production technologies clinic, lecturing and training veterinarians from across the Americas. Dr. Bala authored and co-authored numerous scientific publications and research projects aimed at exploring the boundaries of innovative technologies in bovine reproduction. Our second speaker is Dr. Vincent Martinez. He received his PhD in physics from RMIT University in Melbourne, Australia in 2009. He then joined the University of Edinburgh as a postdoctoral researcher in 2009. Prior to Vincent's academic life, he spent 3 years as a junior scientist to investigate the optical properties of colloidal suspensions and thin films for the paint and coating industry at Comex in Mexico. Since 2009, Vincent developed innovative technologies to characterize movement within suspensions of biological particles such as sperm, bacteria, and algae, as well as synthetic particles like colloids. And he became a world-leading expert in this field while based at the University of Edinburgh. Having authored approximately 40 publications in this field, Vincent has given over 50 international and national talks, and as well as invited seminars. At Dynaval, he heads the R&D team to investigate aspects that affect semen motility, including sample preparation, concentration, and the metabolic health of spermatozoa. Guys, welcome to the webinar, Vet, and it's over to you.
Thank you, Bruce, and good afternoon for everyone. I'm Esteban, and it's an honor to have the opportunity to present this webinar today alongside my partner in Dynaval. So many aspects are considered very important in livestock production, but in my opinion, these are four are very essential: nutrition, health, genetics, fertility. None of them is more important than the other, but they complement each other. In this presentation, we are going to talk about fertility. In livestock production, its process needs to be carried out the best possible efficiency. If we don't manage reproduction correctly, there will not be production. So obtaining reproductive efficiency is not easy, since reproduction is affected by a lot of factors. That's why we call it that is multifactorial. When we refer to this factor, we can name some related to the animals as fertility, nutrition, health. Talking about environment, it can be a affected with temperature, brains, facilities, and the human decisions, management, and protocols. When we compare parameters used in livestock production, it's very important to note that their relative importance. The Association of Breeders classify the animals by their physical conformation or phenotype. And when we talk about growth rate, it's twice important than physical conformation. And when we talk about fertility, it's 10 times more important. Let's see an example. If I have one bull for one cow, how important is the bull to produce a calf? And the cow, let's see, it's 50% important. Now, if we have one bull for one cow, if we have one bull for more than one cow, is the important of each still 50%? No, the relative importance increase more than 80%. And when we collect and freeze semen from one bull and use it in artificial insemination in hundreds of cows, it's increased over 95%. We know that in livestock production in America, in general, most of the activity related to reproduction are focused on the cow, and the bull is not given the same importance. I consider that there is our mistake as a vet, since it's our job to advise those in livestock production. But when pregnancy results are not what we expected, we finally consider the fault maybe with the bull or the semen, but then it's already too late. This shows us that we must take precaution and give attention to the bull health and the health and the semen quality. But what is the impact of poor conception? And how do we know if a bull is efficient? So we must consider the number of calves produced in one breeding season. We must consider that every 21 days, around 20 and 25 kilograms are lost in the final weight of the animal when it weaned. Since the gain weight on average 1 kilograms is gained per day. We know that in USA, the price of a beef is around $6 per kilo. Therefore, over $120 are lost per animal due to delayed conceptions. Prices and losses are almost twice as high in Europe. Introducing the annual breeding soundness examination reduced the risk for the future. That's why it must be a routine practice. Data collected in North and South America has shown that between 40 and 50% of bulls have problems if there are not soundness exams, but this reduced to 10 and 20% with regular checks. The removal of unfit bulls raised the number of conception rates and birth in the first months of the breeding season to generate a greater amounts of kilograms per calf weaning. We must give the necessary importance to the breeding season, to the breeding soundness examination bulls, about that numbers. This research shows typical observation that when evaluating the reproductive ability of a large population of bulls. On the left, we can see the reasons why bulls were discarded: physical problem or poor semen quality. Around 70% have unsatisfactory or questionable semen quality. On the right, we have in more details the physical reasons for discarding. When we refer to breeding soundless examination of bulls, we must consider a physical and health condition. We must consider also copulation ability as a sexual desire, and we must consider the semen quality. Many countries have certificate templates that standardize bulls' soundless exams. But how can we analyze the semen quality? Traditionally, semen analysis has been carried out using visual assessment with an optical microscope, following the World Health Organization guideline. The benefit is that this is portable and can be performed on farm or in a clinic. But the problem is that the assessment is very subjective, with up to 40% differences between vets. Other way is with the computer-aided semen analyzers in the lab that provide quantitative information of semen motility, but they can only be used with careful control of concentration and skilled users. In a few minutes, Vincent will tell us about the last innovation, is the DynaScan semen analyzer. So before we can assess fresh semen, we need to collect it. To collect semen with artificial vagina, the bulls need to be trained and collected regularly. This is more common in a bull stall. As you can see on the top of the left, the artificial vagina is a plastic device covered with rubber on the outside and the inside. In the inside, between the rubber and the plastic, there are water stored at the similar temperature of cow's vagina. It's that what stimulates the ejaculation of the bull. When the bull stands on two legs in front of a cow or a dummy, the operator approach and manually insert the penis into the vagina, into the artificial vagina, and the ejaculated semen is stored in a tube in the opposite end. Other way to collect semen is using the electroejaculator. This is the most commonly used by vets, and for this activity we must take extreme care with the animal. This is an advice that emit electrical pulse rhythmically directly on the mucosa of the rectum, stimulating the reproductive glands. When the bull is stimulated, it puts out the penis and ejaculates. There, the operator has to be attentive to collect the semen in a tube. The electroejaculator is used when bulls live in a pasture or they are not in stable or stalls, because when they live in pasture, they are not handled daily and they are not docile. Then, to perform the analysis of frozen semen straw, we need to be very careful with the protocol for thawing and handling the liquid nitrogen. We must first of all, we have to remove the straw from the nitrogen tank, place it in a thawar with 37 degrees Celsius water for a minimum of 30 seconds. Then we take out the straw and dry it with a piece of paper, cut the opposite end of a cotton plug ease, and introduce the straw in an AI pistol. Now I will tell you about how to evaluate semen quality. Before using any equipment, we can use visual observation following the guideline proposed by Dr. Barth from Canada. First, we need to analyze density and volume of the ejaculate. The average volume of ejaculate is between 4 and 6 milliliters. Also, the color and the appearance. When we have a very good ejaculate, has grainy appearance and opaque color. That means that it has more or less more than 50,000 and 50 million sperm per milliliter. Then we set up the microscope and observe the mass motility. we assess the extent of swirling motion. In this video, here you show swirling motion that I would rate as good sample. If there is no swirling, it may be that the semen sample has been diluted with urine or pre-simulant fluid already, so we need to perform a progressive motility assessment next. To assess progressive motility, we must use diluted semen and use a phase contrast microscope and assess by eye. The percentage progressive motility is a number of cells moving and covering distance relative to the total of cell population. We also assess the speed as a movement force of the speed of a sperm in the microscope view. For fresh semen, we expect the percentage of progressive motility cells to be higher than 60%. And it is lower for frozen semen because of the frozen process. For the concentration analysis, we use the Neubauer cell counting chamber. With the number obtained, we apply the formula. And we must remember that the visual assessment is a subjective methodology, and the results depend on the experience of the operator who performed it. For morphology analysis, we stain a drop of diluted semen and observe the sample with 100 objective. In the picture of the right, we can see the most common shape of normal bovine sperm. There are many ways to classify sperm abnormalities, but the most used are based on the guideline proposed by Dr. Bath from Canada. And we can classify head defects, mid-piece defects, principal piece, and tail defects. Some of those defects can be compensated for by increasing the sperm concentration. So let's see some of the most common defects found as piriform heads, macro and microcephalic sperm, knob acrosome. From the mid-piece, proximal droplets, distal middle piece, the middle piece reflex, and principal piece and tail, coil principal piece. When we analyze frozen semen, we use the seminal post-thaw viability parameter in relation to the stress test at 0 and 2 hours post-thaw. Fresh semen is evaluated differently than frozen semen. Until recently, there has been no single standard in the industry for analyzing conventional or sex semen. There are the parameters here. You can see the parameters that are based on the guideline of Dr. Bath. Now, Dr. Vincent Martinez will tell you about the DynaScan semen analysis.
Thank you, Esteban, for your presentation, and thank you to the audience for joining us tonight. So I'm Vincent Martinez. I'm a physicist with 15 years of experience looking at the physics of swimming microorganisms, including spermatozoa, bacteria, and other systems. And during my research focus, I had to decouple physics phenomena from biology and chemistry. And in that journey, I lead to the development of the core technology behind Dynaval, the DynaScan semen analyzer. DynaScan is a portable device to check semen motility. It can be used at the farm or in the lab. It is portable, but yet delivers lab quality results. And it can be used by anyone with no requirements for prior experience in semen analysis. The only thing that is required is a 30-minute long training, and we mostly teach around good practice for sample preparation. The technology is very easy and practical. You simply connect the DynaScan to the main and to a laptop via a USB cable. On the laptop, there is an application that controls the device. It can be used on fresh semen, on post-thaw frozen semen, including conventional and sex semen. We developed the technology for the cattle industry, for bull semen, but we can also apply it for ram samples. And we're currently extending studies to other species, including equine, pig, and canine. Now, to place the DynaScan in the competitive landscape, as Esteban mentioned, today vets use microscope to perform visual assessment. This is known to have a degree of subjectivity and variability. In the 80s was developed the computer-aided semen analysis. This is the one you see here is not the original version. It is the most recent version and potentially the most common cancer technology out there called the IVOS2. DynaScan is the next generation technology. And the idea behind DynaScan was to develop a technology that overcomes the limitation of the cancer technology. So DynaScan is portable, is user independence, and two independent users will obtain very similar results for the same samples. And that's why I'm trying to convince you tonight. And more importantly, DynaScan can be applied over a wider range of concentration. DynaScan can work at concentration up to 400 million cells per ml, which is about 10 times higher concentration than what a CASA lab-based equipment can do. Now, how do we achieve that? So to explain the difference between CASA technology and the DynaScan technology, I need to introduce a little bit the CASA technology concept. CASA requires high resolution microscopy videos, and using a computer algorithm called particle tracking, the algorithm tracks the head of the cells across the images. And from the tracks, you can extract information. The issue with CASA is that if it's too concentrated, the tracks overlap and you cannot extract any information. So one needs to dilute the solution. But if the solution is too diluted, there is not enough cells in the image, in the field of view, and so give very low statistics. DynaScan uses a completely different approach. This is not based on particle tracking. Instead, we do have an image module within the DynaScan. We send a light through the sample and collect the sample with a digital camera. And what we see on the camera is that the intensity fluctuates over time and space. These fluctuations are due to the motion of the spermatozoa. It could be motile due to swimming, or could be non-motile due to diffusive, or what is called Brownian motion. And what we've done within Dynaval is to develop an algorithm to extract the percentage progressive motility and mean swimming speed efficiently from these fluctuations. Other information can be obtained, such as information about the head oscillation. So the key concept is we do not need to track individual cells, and therefore we use a field of view, a surface area of the imaging, which is up to more than 20 times larger than a standard field of view for a CASA equipment. We also record much longer videos. We can work at much higher concentration, and this is how we can get thousands of cells in the field of view and get very good repeatability of the measurement. This is an example of a Dynaval mode video collected at a farm in a dusty environment. The sperm cells swim nicely. They look like little dots moving in space. And what you see here are spots or dust outside the slide, and these do not contribute to the signal, and we're still able to deliver a very good measurement. We also provide a dual mode within the DynaScan. So we also have access, the user also have access to a visual mode video. So you can still perform a visual assessment, if you wish to, from a higher resolution microscopy, similar objective than using the standard CASA. From this video, you can do your own visual assessment. You can save it, keep it as a proof of record, and share with your peers, colleagues, students, or even customers. But from the Dynaval mode video, you get the values. This is an example, a little study we've done with 5 users. 3 was the very first time to perform a semen analysis, to be wearing a lab coat or being in a wet lab. And yet they observed, or they measured, percentage progressive motility within 1% of someone with more than 10 years of experience in a lab, or a student with 3 months in a wet lab. These 3 persons, which were first-time users, they are not vets, they are not technicians. They were software developers and marketing managers. And with only 30-minute long training, they managed to get very accurate measurements. Reproducibility is also good across devices. From these data, we have repeatability within plus minus 1%, but we do claim a repeatability less than plus minus 3%, which also take into account biological variation at the time of preparing different chamber swabs. Our technology is not only repeatable, it's also accurate. We perform in-house measurements, validation study, comparing DynaScan with a CASA machine, an IVOS 2, which is potentially one of the most common lab-based CASA equipment. But also similar study were performed with external third-party companies, and we find very good agreement between the two. So today, we now have a device that can be used in a semen lab or at the farms with very little experience in semen analysis, and yet can deliver very precise measurements. This is a little study exposing that percentage progressive motility measured by a vet from a visual assessment at a farm using a microscope and its own evaluation methods can bias the measurements. And in that specific case, the vet tended to overestimate the percentage progressive motility of a semen straws. And that was presumably due to the fact that the vet was selecting the most the highest motile area within the cover slip instead of averaging across the whole width of the cover slip. The DynaScan and its protocols really help to get rid of that subjectivity or variability so that the user have full confidence in the measurement. I've mentioned DynaScan can be applied over a wide range of concentration. These are data collected on post-thaw ram samples. Ram pellets or straws usually start at a much higher concentration than bull semen straws. And so we can do a dilution studies here from 10 million cells per mil to up to 400 million cells per mil. This is a logarithmic scale. And we can see a very good reproducibility here. The key message to take home here is that for bull semen straws, there is no need to dilute whatsoever with DynaScan. So you get rid of one step less from the quality control. But two, you also remove any potential risk of incompatibilities between the extenders used to produce the straw and the diluent used for the dilution. Now, the idea is we have that device that measures progressive motility. How does it correlate with fertility prediction? Well, from previous measurements, not performed with a DynaScan, and that was a PhD thesis in 2017 on equine semen, they find a very good correlation between the percentage of progressive motile cells with the percentage of cells believed to fertilize the eggs better, like the acrosome type sperm have. But more recently, there was research presented by Dr. Robaglino at the European AI conference last October. And she found, based on a gene analysis, that the high fertility bulls have spermatozoids with good flagella structure and function. If they have a good flagella structure and function, these high fertility bulls must be correlated with a parameters of motility. So following that, we worked with Dr. Kira O'Meara from the National Cattle Breeding Centers in Ireland, and she used the DynaScan and tested bulls from the Irish population. And from the percentage progressive motility, she correlated with the conception rate. She had thousands of insemination for each, and we find good correlation with the percentage progressive motility. This is still preliminary study, and we are looking to extend further experiments and to submit in a peer-reviewed journal. In the meantime, you can get more information from our blog, from our website. The technique can be applied to conventional or sexed semen straws as well, on top of fresh semen. And we provide guidance about typical measurements collected on farms last year by beta testers and customers. There was about 100 straws tested. We now have data over a couple of hundreds and more straws, independent batches, and we're going to update all the information. What you can see is for sex-sorted semen, we tend to measure lower percentage progressive motility, and this is not unexpected, as the industry is aware that the sex sorting processes are very demanding, intense on the sperm cells. But one user can then compare from their results where they fit within the landscape of other measurements. Now, one specific advantage of the DynaScan is one can perform a thermal resistance stress tests in an automated way at a single click and go. So one can place the sample within the DynaScan and decide to monitor a motility as long as you wish. In that specific case, we monitor motility for 5 hours. And so we have the mean swimming speed as a function of time. And what we witness is a transition from a high speed to a lower speed within a very short time. And what we witness here is a transition from aerobic, fully oxygenated environments to anaerobic, fully where the cells are fully consumed the oxygen available within the solution. But yet the percentage of progressive motile cells have not changed during that transition and can maintain motility in that case for a period of 4 hours. From that, we can define a new parameters we call the sustained motility lifetime, which is basically the time for progressive motility to reduce by half. In that case, it will be approximately 4 hours or more. While this could be used as a new tool for quality control to assess semen quality, it can also be used for research environments. You could look at metabolic health. You could look at potential damage from toxin due to the metabolic activity. You could look at the importance of an extender or developing new extenders, or potentially looking at the importance of a specific seminal plasma. Now, not all straws have the capability to maintain swimming in anaerobic environments. This is an example where we perform time dependency measurements over 5 bulls post-thaw from different ejaculates. Each corresponds to 1 bull. For 4 of them, they could maintain motility over a decent time, over a fairly long time, 3 to 4 hours. The one really stand out, bull X. Starting at 45% progressive motility, will pass any of the quality control, probably, but within 30 minutes, motility collapsed and ceases. Looking more details to bull X, checking again the same batch, number 1, with the orange straw, we find a reproducibility of that. Something is wrong with that batch. We also tested other independent ejaculates, independent batches, and you can see a rather different response from it. While eventually batch number 2 and 1 will potentially have a very similar progressive motility at time 0, over a certain time, the response is really different. That also exposed that one need to check every independent batch before to be released. Now we know that the conditions surrounding the oocyte in the ovidic fluid has a low oxygen content and potentially even anaerobic environment as the oocyte consume a lot of oxygen. The question we pose in that webinar is, could such new and innovative time dependency measurements could be used to advise or improve artificial insemination protocols? On these words, I pass on to Esteban. We will talk more about artificial insemination.
Okay, thank you, Vincent. And thanks to the DynaScan, we can see that semen quality can differ enormously between samples, but not only by the percentage progressive motility, but also the lifetime over which the sperm cells can swim. Let us now learn about artificial insemination and consider the AI protocols that are available for us. First of all, we must refresh what is artificial insemination. We know that it's a biotechnology that consists of the deposit of the sperm into the reproductive tract of the female. But when we should put that semen? Before, during, or after ovulation. We must consider that we must introduce it in the exact moment, combined with the ovulation. To understand the moment of AI, let's see a summary of what happened with sperm before they are ejaculated into the vagina. The semen, when it is ejaculated into the vagina, find the first barrier, that is the cervix. the sperm are matured, but they cannot fertilize yet. The first barrier, as the cervical folds and crypts, remove the seminal plasma, and the sperm does not move. So the uterine tract has the physiological mechanism as cervical mucus secretion and muscle intermittent contraction to transport sperm to the oviduct without the active participation of those. So there are two ways that the sperm can be transported. One of them is the rapid phase transport, where most of sperm has damaged membranes and are probably dead. They don't move and remain in the lumen of the uterine tract. Many of them are eliminated outside the uterus, and a small number are transported to the oviduct with a few minutes and probably fertilize a few ova. This forward and backward transport is done by the muscle contraction and fluid secretion of the uterus. The other way is the prolonged phase transport, where live and motile sperm can adhere to the epithelium or enter the folds of the cervix and uterus, and they can progress forward and reach the oviduct within being eliminated outside the uterus. The sperm that capable of fertilizing ova arrive in the oviduct about 8 hours after mating and are held in the isthmus. That's why we consider as the second barrier, about 18 hours more until ovulation. Then the sperm proceed to the site of fertilization near the junction of the isthmus with the ampulla. This is demonstrated by this work that evaluated the percentage of fertilized ova at different times after the start of heat, where you can see when the time of 12 hours before, after there were 50% of fertilized ova. During this pass through the uterus to the oviduct, where sperm are deposited due the low level of cholesterol, glucosaminoglycans, presence of calcium, also the contact of the sperm with the mucosa and the uterine fluid, the sperm capacitation and acrosomal reaction occurs. Because of this, cell surface component as glucoproteins that were added in the epididymis are removed. Also, the sperm become hyperactivated. Also, changes in the acrosome membranes occurs, releasing hydraulic enzymes that allow that the sperm can join and penetrate the oocyte. So as we cannot see the ovulation, we need to calculate when it happened. We know that the ovulation occurs between 24 and 30 hours after the start of the heat, and the heat has the average duration of 24 hours. That's why it's very important to recognize which cow is in heat and when the heat starts. In that picture, you can see the cow that's allowed itself to be mounted is in heat. Because of that, the insemination should be done around 12 to 18 hours after heat began. This is because we need to give the sperm time to pass through the uterus and reach the oviduct to fertilize ovas. As sperm live approximately 20 to 30 hours and the ova 8 to 10 hours, it's better that the sperm arrive at the time of ovulation or little before. than the ova wait for the sperm. The optimal time for insemination has been explored with high, medium, and low fertility bulls based on percentage of non-return to heat. This work suggests that with bulls of low fertility, it is possible to improve pregnancy results by delaying the time of AI and at the end or after the end of a heat, but also several hours before ovulation. This is very, very important. It has also been studied in embryo production, where the percentage fertilization was higher when the AI was performed 24 hours after the start of heat, but with lower embryo quality. You can see few good quality embryos and more degenerate embryos. These works demonstrate that to obtain a balance between fertility and embryo quality, the insemination should be done 12 hours after heat began. We talk about the importance to recognize the sign of heat. So if we talk about insemination or bull's mount, the best time is around 12 to 18 hours after heat began. But heat detection is not an easy task because many factors interact each other and can make it very difficult to determine when the heat begins. For example, environment factors such weather, if the cow are in mountains and grassland, rainfall, temperature, also the breed of the animal, social interaction between them, etc. There are a lot of factors. To avoid having detection, to detect heat, for many years, the moments of ovulation have been studied according to the application of different hormones, performing the insemination with the control of follicular phase. There are currently a lot of protocols that determine the optimal time to perform fixed-time insemination, controlling the follicular and luteal phase, depending on the type of animal which we are working with. In order not to go into details with the different protocols, because there are a lot of protocols, those are the most traditional protocols that represent the numerous exciting protocols. The use of GnRH, PGF, progesterone, estrogen allow us to manipulate the luteal and follicular phase of the female estrous cycle and to perform the EI at a certain time, always 12 hours on average before ovulation occurs. This is true when we talk about conventional semen. I had to mention that there are still some countries in America, like Argentina, that where the use of estrogen is not prohibited yet. But when we talk about sex-sorted semen, this change. Although the exact reason is still not well determined, but it is known that delaying the fixed time moment, the fixed time artificial insemination with respect to the removal of the device with progesterone, you could obtain better pregnancy rates, as you show in this work. This may be due because the process of sexing sperm pre-activates them and they not live the same time as non-sexed sperm. Also, as well as that the straw of sex semen has less amount of sperm than conventional semen. That is why it is better to deposit them in the uterus, close it to the moment of ovulation. So now we would like to open up a poll to explore how would you propose to use sustained motility lifetime measurement to help you make decision regarding AI on farm.
Right, folks, the poll is up. It's open. All you got to do is just simply click on the answer that you feel represents your opinion best. It is something that is absolutely anonymous, and don't feel shy. Give us your opinion, and it really does help us to, or help the speakers to know where we're at and where we're going.
So for the poll, I'd like to make a little introduction here. So the idea is we have on that slide is the question we ask is how would you use this data, the time dependency measurement of the percentage progressive motility, to potentially guide or improve artificial insemination protocols. So we have an example of here 3 sexed semen straws, post-thaw, bull A, and that got a percentage progressive motility from the very top of the sexed semen straws. We can maintain motility for 2 hours. Bull B start at a lower level, about 10%, show a little increase over time and a decrease with a SML, a sustained motility lifetime of about 80 minutes. Bull C is very similar, but the decrease in motility happens over a shorter time. So the bull C got a shorter SML. The questions we're asking you here is which bulls would you use for artificial insemination? So which one will you use based on the heat detection?
All right, folks, as I said before, don't be shy. It is completely anonymous. All you need to do is just click on the answer that best represents your opinion. We've got a few more coming in. I'm going to give you another 10 seconds before I close this poll and we move on to the next one. That's it. Starting to get more answers coming through now. Excellent. 5 more seconds. Right, Vincent, let's move on to the next one.
I don't see the next question. It's coming here. Yeah, perfect. The next question is, so in the context of what we've seen with that Esteban explained around fixed time artificial insemination, which bull would you recommend fixed time AI? Bull A, bull B, or bull C?
I think we're starting to get used to this, guys, because the questions are being answered a lot quicker. That's fantastic, folks. Let's keep those responses coming in. We'll give you another 15 seconds because I'm still getting a lot of answers coming through. Just click on the one that you feel most represents your opinion. And let's close that and get to the next one then.
So in the context that Esteban explained that potentially what has been observed from academic research, sex semen tends to get better results with fixed time artificial insemination at a slightly later time. In that respect, for which bull would you delay insemination?
Oh, Vincent, I think this one's got people really deeply thinking because the answers are a little bit slower coming in.
Okay.
Come on, guys. For which bulls would you delay insemination? Bull A, bull B, or bull C? Here we go. Right. And a couple of stragglers still coming in. Fantastic. Right. Let's move on to the next one then.
So, yeah, so something about double insemination. Esteban did not have time to talk about a double insemination that may be used in some cases based on again, the results in the progressive motility. Which one would you recommend double insemination?
Excellent. They are starting to come in. Guys, remember, sitting on the fence gives you splinters. So let's get off that fence and give us your opinion on these questions. That's the way. Yes, lots of them coming in now. I think I was being unfair there, guys. I think they were just deeply thinking about it. So that's fantastic. Right. And let's move on to the last one.
So something that Esteban didn't have a chance to talk about, but as you may well be aware, fertility success may depend on the age of cows. Cows, heifers, and the age and so on. In that context, which bulls would you use on older cows?
I think we've got the hang of this now. And we've got quite a lot of answers coming in. There's still quite a few people that haven't given us any answers yet. Oh, yeah, they come. That's fantastic. Come on, guys. Another 10 seconds, and then we will stop this one as well. Last stragglers are coming in now. Oh, difficult question. Right. And that's now closed the polls. Guys, just a little bit of a difference from what we normally do, where we reveal all the results now. The team from Dynaval will make those results available to you in a special way after the webinar. So stand by, watch your emails. They will be coming your way. Guys, I think we have a couple of questions coming through, if that's okay with you.
Yeah, that would be fantastic.
The first one, I think, is aimed mostly at Esteban. Esteban, you were talking about water in the artificial vagina for the semen collection and that. Jose wants to know, what temperature would you use, and do you need to be specific with it?
It is very different between bulls because there are there is a temperature for each bull. Maybe you must consider that start with 38 or 39 degree, and then try in which temperature this bull is going to ejaculate. Maybe you must put a higher temperature, and then you must put it down, but you must to check which temperature is the best for each bull.
Fantastic. So it's a bit of trial and error sometimes if you're not getting the results that you're hoping for. Vincent, speaking of results and that sort of thing, the Dynascan, is that do you think being widely used to set standards, or do you think it's going to improve standards over time? As my first part of the question that's come through. The second part is, will it become the norm for different studs and semen providers to be using?
So we believe, so Dynascan really is the first technology that can be used across the industry. So it can be used at the farm, it can be used by vets, and the same technology can be used in the semen production or processing labs. And this is the first. And yet, if you measure these two environments on the same sample, you get very good reproducibility. So we believe that Dynascan can help the industry by providing the same technology from all environments. On top of that, based on the time dependency and its precisions, we believe it can bring a new tool as a quality control. So there is automated stress test. Stress test is already used as a quality control, but not as a function of time. Let's say they perform at 0 error points, and then each labs may do a 2 hours, or maybe a 3 hours, or maybe anything else. So there is no clear standard across the stress tests, and the Dynascan can bring that's new standards that could be used across the whole industry.
Excellent. Yes, and certainly it's a fantastic technology. So we hope that it does become a standard measuring technique. There's a couple of questions have come through, but basically the difference in percentages of failures of bulls for breeding soundness across different countries. Is that something that you can briefly give us an answer on, Esteban, rather than spending too much time. I don't want to run out of time on a whole other webinar.
Sorry, Bruce, could you repeat the answer?
Yeah, the questions that have come through is basically about the percentages of bulls failing breeding soundnesses exams and why they vary so dramatically between different countries. One of the examples was given that Argentina, for example, is as high as 16.5%, whereas the UK is very low.
I don't remember exactly the reason why is that pathology is so high in Argentina in this study, this work. I think I don't remember exactly because there were a lot of years ago, but I can remember that could be possible because the season of the year that was made the study, and maybe in relationship with what the bulls ate at that time.
Okay, fantastic.
I'd like to comment that it was an interesting talk by Ian McCormick at the last BCVA conferences in the UK last year, and he performed 700 bull soundness examination and did some statistics. On average, it was 1 out of 5 bulls was failing the breeding soundness examination. So it's not that far away from what Esteban has presented.
Oh, excellent, excellent. Esteban, I think this one is aimed at you as well. Peter wants to know, if a bull hasn't served for a long period of time, do you need to have him collected more than once, as the first ejaculate may be stale?
If a bull maybe it's better that you put the bull with the cows few days before, because if there was such a long time that the bull doesn't serve, maybe could have some abnormalities in the spermatozoa, but there is no problem because with 2 or 3 ejaculates that could be resolved. So if there were a lot of time without serve, maybe I prefer to put with some cows a few days, and then it's going to be ready for the breeding season.
And the other thing you could do as a fail-safe is put his sperm through a Dynascan and test it, and then you will get motilities. There we go.
Yes, that's right. You could collect its semen and make the analysis and try to see what kind of problem could it be.
Yeah. The last question that we've got time for tonight, I think might be a whole other webinar on its own. So I'm going to put you on the spot here, Esteban. 1 minute answer. The factors that might influence semen quality after storage.
Oh, if you you have control of the level of the nitrogen in the tank, you are not going to have any problem. But many of those problems that maybe this vet ask is about a bad way to conserve this nitrogen tank, because everyone forgot to refill the tank, or if you need to see which straw you have in that tank, you spend a lot of time with the straw outside the tank, and it's maybe damaged all the sperm.
Thank you for that. I think clearly the Dynascan can provide quality assurance on straws on farm where it really matters, and is providing new insights to help guide artificial insemination and to improve productivity and sustainability. I'm sure the team will be delighted to help anybody on this webinar or anybody else who would like to learn more. The details are on screen now, so please feel free to get hold of them. You can call them, you can email them, you can go online and go and have a look at their website. And both Esteban and Vincent would be more than helpful to with answering those questions for you and giving you more information. I know they've got a team that know what's going on, and as Vincent said in the beginning, 30 minutes of training and away you go. So that's a fantastic improvement in on-site technology. Gentlemen, thank you for your time tonight. We really appreciate it. And to Dynaval, thank you so much for your sponsorship of tonight. To everybody that was on the webinar, thank you for your time. I hope you have learned something, as I know I have. It's amazing to see this technology is now available and can be used literally in the field, which is fantastic. So thank you, gentlemen, and thank you to everybody for participating and giving us your time tonight.
Thank you, everyone.
To my co-presenter and hiding in the background, Dawn, as always, thank you very much for all your hard work and for making everything run smoothly. From myself, Bruce Stevenson, it's good night.